Welcome to a new test and teardown video. This time it's a Hewlett Packard 3708A noise and interference test set. I think it was released in 1989, and this one is very, very special. I'm not super sure if I can use this today for my normal radio amateur hobby or radio transmitters, receivers and stuff like that, really, because I use some other methods for modulation and signal to noise ratio measurements and stuff like that. But this here is more for digital communication, and it's of course for the IF chain. So you of course disable the RF frequencies, and then the RF should be in the range 70 or 70 plus minus 20 and 140 or 10 to 200. And the idea is we got a noise output, and then it will add a noise, and then you can measure signal to noise ratios. You can measure the noise level and all that kind of stuff in your receiver IF part of it. I don't know if this one works. It is probably haven't been tested for many years. I will try and power it up in a minute. Got all this local and yeah, okay, now this here we go. This one sticks a little bit. So this tells me we got a little bit of sticky, dirty inside. So I better open and inspect a little bit. Here at the rear, we got the voltage selector switches, and it was set for 220. So this also tells me it was quite a lot of years ago since this one was in use. We got an external reference input, and they say here you need to terminate this one if not in use. That is a little bit funny. This kind of dust and dirt we have here, I think there is a fan on the other side here. We got some transistors and see, probably suck air in and out here, something like that, right? And of course the IEEE port, I would assume. So this unit is just beautiful inside, of course. So if we start with the power supply, right here we got the high power transistors for, of course, the most power consuming voltages, of course, and we got individual fuses and all the capacitors, and what is that, 2 large bridge rectifiers. We can only see, yes, here we go, with a little bit of light. And that will be the power supply controller board. We got 2 of them. See, we got also some extra additional voltages and stuff here. And that will be the main CPU controller board. And it is a little bit interesting because the CPU is the 8088. Copyright Intel 1978. So they're using old tech. And the software in this one is from 1988. But I find a lot of ICs with date codes from this one is from 90, 91. And I think I also found a few 92 date codes. I think it was down here somewhere. Yes, that one. 92, right? So far, I just guess this unit is from 92. We got some digital interface board. We got some analog interfacing some analog stuff here. Power supply checkpoints, quite nice here, so we can see all that is working. Everything is really beautifully done, and I like power supplies. They're using gold. Look at that. Gold plated, everything. Nice, nice. Good for reliable connections, and it feels nice. Look at how clean it is. And that is because it's gold plated. Lovely, lovely gold. I gotta show you something fantastic here about the way you can service this thing. So you simply unscrew the main board here, and then you can do the flip, and they made this. See this piece of metal here goes to this and this little screw here. So the idea is you lift this up, and then you can tighten this screw in any position to hold this, and this way you can access everything down here while you have it flipped. Yeah, I should probably do that. See, that was real easy. And now we can see all the fancy parts down here. And there's another little software package down here from 85. This is probably the software that controls this analog devices. 1813. And then there's the additional software for it. That's quite nice. But I think it's more. Oh, this is just a correction table because it's going to the AD converter. And then it's correcting linearization, logarithmic stuff probably. Yeah, I don't find anything broken or cracked or leaked or brown or anything like that, so I should probably just try and power it up and see what happens. I just really love to enjoy the build quality and all that. Switched amp, and what is that? Probably an attenuator with some relays, and everything here is just built like a tank. So high build quality. Look at the connectors and all the neat boxes. What is that? It says whatever it is. Yeah, I'm gonna go and play a little bit with this. Oh, down here is another little attenuator from Hewlett Packard. Of course, this is the classic attenuator. Let's look a little bit at the bottom. And everything here is nicely labeled. And you can now access the bottom of each little module. I promise you, I will open everything here so we can have a nice little look. I already had a little sneak peek through the holes, and I see some big hefty power transistors. Look at that. Yeah, I look so much forward to looking into all that. And that is a little bottom view from the power supply. Why do we have a little push switch to reset something there? And, oops, what is that? That was good, I saw that. This is not supposed to look like that, right? Look at that, sticking halfway out. I have to fix this before I power it up. There's a missing power supply there, I guess. So that was easy to fix. I just clicked it correctly into the connector. But I just really want to show you the build quality of this unit. So you've got some filters here so we don't get dust into the module so much. And the cable and the grounding, even that is beautifully made. And here we got the power and stuff into the modules using feed-through capacitors for high frequency isolation. Oh, that is just beautifully done as well. It looks a little bit like they are soldered into the place, or is there really maybe a little? Yeah, look at that. It's connectors. So that means it is possible to remove this board, pull this out, and then you can take out the different RF modules. Oh, lucky. Good service friendly. And I really like the way that you can access those modules from the bottom as well. And that is the bongo. I'm still going through the nice unit here. It's just so beautiful. HP super quality design. This is the crystal oscillator, the reference oscillators. We got two different crystals here, and I bet you use those two signals here to select the different oscillator, right? And all the modules, they use the same little amplifier. So this is a ceramic substrate, and this here is the signal path. So there's a tiny little amplifier here, and then it goes to the final stage, and then it's out. And there's a little op amp here, and this one handles the biasing of those two transistors. So that's basically how this little amplifier module works. And if we go to the filter section, so this is how they select the different noise filters. We see we got quite a lot of different filters going on. So here's an additional one. We got the input here, and this one goes here, and so on. But I really want you to see this really cool detail right there. A 5-way diode selector. Oh, that is so cool. So by biasing those diodes, you simply select the RF signal path through this filter or through that filter, this way or that way. Isn't it just fantastic the way that they figure this out? And there's of course another one in the other end, and that will be the bias selectors. This one is the noise source, and right here we got this special part that makes the noise, and then they amplify that broadband noise 3 times, and then the signal go to, this is a little amplifier, but also the variable gain stage for the noise source. And then, of course, the noise goes to this filter section, and then you can select what type of noise you want and what kind of frequency ranges and whatnot. You can also see that this is the common output of that filter, and here the signal goes into some other units, and this is also a level gain selector unit, and output here goes to the little output amplifier, and look at that one. It's called a BFQ34, so it's capable of delivering almost a half a watt. They're of course not using that kind of power, but you just need all this headroom to handle the noise floor correctly. So there's a little preamp here, and then of course the final, I believe this handles the biasing, but that's all there is to it, basically. I just had to open some more modules here at the bottom. This one is called post attenuator amp and then switched amp. And I believe this is of course the input to all those 4 amplifiers. So that is the bottom wire here. And it comes from this attenuator system right there. I think this has got to be some attenuators. And here is a switch. There's probably a diode system in here. So this is the control, and there's only this one wire into this whole module. So I bet it switches the input between those two. Well, look at that. Here is the output from the amplifier. And there's another output from the amplifier here that goes to another set of attenuators up there. And then this attenuator goes into this module called the injection assay. And then we got some connectors that goes back all the way to the rear of the unit. I really want to look in there as well. It's the... Yeah, let's open and inspect a little bit more. This is so beautiful. So this one here is called the injection assay. And it takes quite a lot of different RF signals and selects them. Look at that one. I mean, some of the parts in here is designed like really gigahertz electronics, but this unit is only a 200 megahertz unit. So I really find it so cool the way they designed this. What have we got here with those super beautiful chips right there? No idea so far, but it's probably some switches or some mixers. So this one here is a switch, and it controls the different levels you're measuring, so you can compare a wanted signal from a noisy signal from a non-noisy signal, and then it is the difference you measure. And I'm a little bit confused about, is this a mechanical relay or is it diodes? But I have quite a good contact between these two, and I have open here, so I think it's a relay mechanical switch. Really? I still haven't figured out exactly what is this one doing here, but it comes from the output of this one. I mean, what's that one doing? There's probably a signal going down through this board to the other boards on the other side. Otherwise, it doesn't really give me a good idea about what is going on here and why. Why is it we have all those signals here and then two additional signals that's not in the connectors like that? That's also a little bit weird. So let's try and test this wonderful unit. First, I prefer to turn on mains and see nothing bad happens. And I am ready here. I think it goes through some signals. It's still in the calibrate. It will take a little while. It measures the levels of the noise source, and yes, exactly. It is now ready. So it passed the self-test. So now it measures the level. So this is the noise floor, and we can now select the different frequency ranges. I should see something here. Power meter. So let's just try and connect everything here. So I just feed everything through. I'm just playing around with the different features. First of all, let's try the power meter. So the power meter is just measuring input here in whatever frequency range we have. So the output oscillator here is always active as well. This one should be 0 dBm reference. So if I connect these two together, I have a loss of 0.5. And if I change the other frequency, see? I think that is a little bit weird. Why would I have less at a higher frequency? Maybe there's a little bit of calibration difference between those two frequencies. Well, that is the power meter. We can also go into the noise generator, and yeah, of course it will calibrate and all that kind of stuff. And here we can play with the, I think this is the noise output, right? And then you need to hit this one again, I think. And then you can change. Obviously I don't have any gain here. You should have external gain. And that is of course why I don't get any good readings here. No, it's not all. It's really not. I was expecting something different. Well, noise generator, and here. So now we are in dBm hertz. Okay, so what if I take this? No. So maybe the noise generator is dead. Yeah, it looks a little bit like that, right? So if I go into the power meter, in power meter mode I can't turn on and off the noise generator. Maybe I will just turn on my spectrum analyzer and play a little bit with this. But it seems like it's not super much alive. And what do you know? The noise source and all this stuff is actually working. Look at that. So this is this full span here is 0 to 500. And I got the 10 to 200 enabled. Let's try and click the next one just to see what happens when we play with the different filters. And it takes a little while. See? We can try the next filter. And this one should be more narrow. Yeah. So all those filters actually works. Fantastic. I'm quite happy about all that. So I'm probably gonna play a little bit with the input in different noises and all that. I'm probably gonna play with my external filters. We can also put external filters here instead of the built-in filters. And that is actually a real smart way to also work with this one. And of course you need to input the filter bandwidth for the noise calibration and all that. Readout should be working, but so far I think it is almost working.